In this video, we're going to be talking about the relationships between pressure, volume, and temperature in gas. So, in order to find out the relationships, we have to figure out what these words mean. So for P, which is pressure, is the physical force exerted on or against an object by something in contact with it. So basically, if you're looking at it in this scenario, when gas is in a container, it's basically how intense it is when it hits the walls of that container. For volume, which is in this case will be measured in liters, is how much gas there is in that container. And then for temperature, simply is how much heat there is in the gas, or how cold it is. And this would always be measured in Kelvin. So, in order to find it out, we have to use this little simulation that helps us out with this problem. So first, we have to find out what volume is in relationship to temperature. So in gas, in this container right here, if we change up the volume, or change up the temperature in this case, we can see how the volume reacts to it. And as we can see, the temperature goes down. As the temperature goes down, the volume also goes down. And when the temperature goes up, the volume also goes up. It's pretty cool. So now we can know that these two go up at the same rate, as well as going down at the same rate. So, yes. So in temperature and volume, when temperature goes up, volume goes up. When temperature goes down, volume also goes down. So for pressure and volume should be pretty simple. So for pressure, ATM, and volume in L, we can figure that out as pressure goes up, the volume goes down, and as pressure goes down, volume goes up. So basically the opposite of each other. So now we know the relationship between these two. And then for the last one, we have pressure versus temperature. And for pressure versus temperature, we can see here, turn off the RSPE, and then as we move temperature down, we can see that the value of the pressure also goes down. So we can use that.